Hi, welcome back. This is parts video 3 to review all the parts that was done during the Sias testing and demo videos. There are 4 rotor functions. Today we're looking at the rotor function specifically. There are 4 rotor functions. I call them step, increment, sweep, revolve. And those are the 4, and you can obviously switch it off as well. The step, what I mean by step is responsible for that 2 little holes, which is actually 3 little holes. How the step works is it's got 12 programmable positions. It does not work on degrees or anything, it works on physical steps. So if you create a rotary tool for you, like a axis or turntable, you have to count or figure out how many steps is 1 revolution, and it works from there. So for this one, I could set step 1 is there, so the rod will come, it will spark a hole, lift up, move to step 2, which was right next to it, make a hole, lift up, move to step 3, make a hole right there, and the job is done, since it knows it doesn't have any steps left. You can program up to 12. Now, to calculate where you want them, you obviously have to take your amount of steps per revolution, and you have to calculate that by 360 degrees, so you can figure out how many steps is per degree, and then you can program that in manually. That is if you want odd locations on the steps. If you want even locations, increment is a way easier option. Like I said, with step you can do up to 12 positions. With increment you can do up to 100. It actually starts at position 0 and runs up to 99. Here you just input your amount of steps per revolution on your whatever jig you have, and you just say your part you want to have, I think for this case was 12 increments, and it'll just start drilling holes, increment 1/12 per 1/12 of a revolution, and carry on until it's done. So very easy to index hex shapes, octagon shapes. If you want safety wise through bolts, line it up and it will run through that. Other thing which it's useful for as well is if you're manufacturing, let's say, nozzles. You have a big table, rotary table, 100 positions under it. Your nozzles just plug into a little hole, and you spark the hole in the nozzle, it rotates to the next one and moves on to the next one. So you can have like automation function basically built in. You can use it pretty much however you want. The third function is sweep. Now this function is, I wasn't sure in the beginning whether it will work, but it's awesome. It will cut between 2 positions and move forward and back to create a groove, which gives you some abilities that I've never seen before. I'll get into that in a little bit. It gives you 12, you have the option of 12 pairs. Now the reason why I call it pairs is the start and the stop position. That's your 1 pair. So you can basically cut 12 slots. What I did here is I cut a little short slot, longer slot, and then a much longer slot. And it will actually move forward and back until it reaches the depth or runs through whatever your setting is. So this gives you quite unique features. And the 4th option is revolve. With revolve, it'll just go down and it'll actually spark while it's revolving. You'll see in the video from time to time it actually stops sparking, but it's just because it's extending the rod and doing its checks just to make sure that everything is still lined up, everything is in the right position, and the spark gap is correct. Now this is the example part that covers all 4. So this covers all 4 functions, but there's better examples of the unique functions. That was aluminum tube. This is 0.4 mil spring steel, stainless steel. Here I did a sweep, basically almost broke through. I just stopped it shy of breaking through completely. So that was a sweep. That was a step, so it made a hole, another hole, moved over, put 2 holes right next to each other without affecting the hole itself. It's not like it's running across and making a big oval. You can see the little parts in between of it, almost creates like a figure 8. and then I put another hole over here, and then I did a increment. I think that might be 20 holes. I didn't count them now. Obviously there is a bit of an issue there in those 2 holes. What happened there is, as you may have seen on my videos, it wasn't really the most rigid setup in the world. Most of the thing was hot melt glue and cable ties, and I did that for a reason. It is just to illustrate that because it's a non-contact process, you don't really need a heavy cast iron based machine with micron clearance and high power motors. You can use something small and lightweight because the process allows it. However, be careful of vibration and be careful of these 2 things, because my 2 things wanted to bump everything while it's moving. Okay, so that is one of the operations. Then back to the increment. Here's another increment operation, which is pretty nice. With this increment, the nice thing here was it wasn't done straight, it was done at an angle. So there's no way you could ever be able to drill anything like that, because it's right on the edge. It's almost like tangent, and it'll spark it, pull it out, index, spark, index, and I'll just run through the whole sequence. Yeah, I just stopped it short because it's kind of pointless having it right the way around, just to illustrate. And there's another little one. This one ran all the way around. This is one in my demo video. You would have seen that on the demo video while I was indexing, and all of a sudden there's 2 little holes. I bumped the rotary head while I was holding the flushing tube. The reason why I was holding the flushing tube is the water kept on splashing on the camera's lens. So I tried to redirect most of that splashback, so I don't have to wipe the lens the whole time and interfere with the footage. But in the process between wiping the lens and holding the tube and trying to line everything up, I bumped the rotary head, and that caused that double hole. Basically, it as it went down, it created 1 hole. As it was lifting up, I bumped it, touched off again, and thought, okay, I reached my next hole and started doing another hole. That being said, here's another one. This is also 1 more holes, and they're ridiculously close to each other. With this, I think this one was set at 50 increments. So if I would have left it carry on, we've done 50 holes on the circumference of this tube. It would almost have perforated it. So it's just a nice little pattern, which I interrupted. Then to the revolve function again. This was also with a 1mm rod on this little gear. The advantage with this unit as well is it follows the contour of the material. You'll see in some of these videos it runs like that. It does not run on center, it almost runs like a cam. And the machine doesn't really care. It'll pick that up and will actually conform to the shape. So you can have something with a off-center disc or anything, and it will actually follow that. Here's an example of a gear. It followed the pitch of a gear. So it followed the tooth, went down into the valley, followed the tooth again, and ran up and down like that. It didn't just make a line right across. Unfortunately, this one, the rod was thicker than the little valley there is wide, so it didn't go all the way down. If I let it run longer, it would have gone all the way down because it would have created a little gap there on the sides. But with this, you can see it still runs up, runs down, and runs across. So there is advantage of this as well with unique features. Here's a little test part I didn't have in my demo. This is just a revolve with a really thick rod. This was done with 0.75mm copper wire, if I'm not mistaken. And there's a little groove. Anyway, this was part 3 of the parts review videos. Next we will do review of the unit itself, more functions, and in the next couple of days we'll start showing videos on how to use it. Cool. Hope you'll be joining us for that, and please support our Indiegogo campaign. Links down in the description. Thank you very much. Bye.